I have a fairly long presentation that usually takes me almost an hour to do, and we have 40 minutes. So I'm going to try and squeeze the time as much as possible. Let's get started. So what I'm going to tell you about is the story behind PHP, and specifically PHP 7, a bit about the evolution with emphasis on performance, and then also talk a bit about what we expect to happen in the future. Not so much, again, on features, because it's a very dynamic evolution where it's very difficult, next to impossible, to predict where it's going to go, but more, again, in the context of performance. So a quick introduction about myself. I have 3 daughters. I don't have any boys, so this gives me a great opportunity and a great excuse to do all sorts of things like that and say that my daughters did it, when in fact it was me. Sometimes they do that stuff too, but usually it's me. I'm a photography enthusiast. I almost always carry my camera around with me. I'm crazy about spicy foods. I had some pretty good ones here as well. I started programming since the age of 12. My initial language was GW Basic. Anyone here ever used that? Yeah, there's a couple of hands. I feel for you, sorry. And the last thing I did before I started getting involved in PHP was programming CGIs in C++, which is a downright horrible experience that I really don't recommend anyone to do that. But at the time when I did it, I thought it was very clever. I want to tell you a bit about how I got involved with PHP. It was my first and I guess main involvement with an open source project. I'll tell you the quick version of it because we really don't have much time. My colleague and I in university, Andy Gutmans and myself, we had to hand in a project that was supposed to be a shopping cart, an e-commerce site. The year is 1997. There aren't too many web-based web tools to create that sort of stuff, and that was actually a 5-point, which is a lot in this university, a 5-point project, just to create a basic shopping cart. And there were 6 or 7 different groups of students that did this project. All of the groups picked Perl to create this shopping cart. For us, for Andy and me, I knew PHP FI from work. I was working at the same time as studying. And I told Andy, I know this thing. It's much simpler than Perl. We should use it instead, and we can do this project really with the minimal investment, just do it in probably 20 hours or so and be done with it. And I convinced him pretty quickly, convincing the instructor that it's okay to use PHP was a bit more difficult because she never heard of PHP FI, but eventually we managed to convince her. And then, once it was already set in stone that we had to use PHP FI, and she told us, by the way, if you're going to have trouble using it, you're going to be graded for it. You're going to lose points if the tools are not good. Once it was already too late to change, we started implementing the software, the shopping cart, and about half an hour into the implementation, we bumped into a problem. A syntax error or a parser error, I don't remember what it was exactly, but it was essentially a parser error, like I'm sure each and every one of you have experienced, whether in PHP or in any other language. What do you do when you have a syntax error or a parser error? I don't know about you. I guess you, like me, you go to the source and try to understand where you're wrong, what kind of mistake you made, whether you forgot a semicolon somewhere or something like that. And we did. We went back to the source code. We looked at it. We looked again. We tried to kind of switch lines, move things around, shuffle things, and we really couldn't understand what was going on. Until at some point, probably about 10 minutes later, we came to the conclusion that actually our code was fine. The language was not quite understanding itself. The code was okay. The parser was not properly understanding it. So thanks to the fact it was open source, and combined with the fact that in the previous semester we took a compilations technique course, so we already felt like experts, which obviously we were not. But we felt that we could probably maybe fix it. We looked at the source code, and to our surprise, it was kind of very, very surprising. And I don't know if there are any mechanics in the room, but can anyone tell what's wrong with this car? No? Okay, so that's the feeling that we had. I don't know if you can see it at the back, but those are two white mice that are rotating the engine. And that's what it felt like. It was amazing that it worked as well as it did, because it was really written in a way that was, I don't have the right adjective, but it was not the way it was supposed to be written like. So we contacted Rasmus, the guy who wrote it, and we were young and dumb and we were not very polite, but we asked him in a less polite way than I'm going to describe now, what the hell were you thinking? Why did you do it this way? And he was a lot more polite than we were, and he replied within a day or so that he's not a computer science major. He did it for his own personal purposes, and I thought maybe others would find it useful. And if we can fix it, if we can help improve it, great. That's how he knows how to do it. So I'll fast forward, because I wasn't being true when I said I'm going to give you the quick version. I already lost a lot of time. We ended up rewriting the whole thing from scratch. To our surprise / happiness, Rasmus agreed to actually stop working on PHP 2, his implementation, and move to work on our rewritten implementation. In the process, we also invited several additional people to join, and that's how the multi-person PHP project began, essentially. Today, it's already in the hundreds. This is in year 2000, when it was probably the first and last time that it was practical to bring everyone, or at least almost everyone who was working on PHP into the same physical location. So I wish, well, actually, a laser wouldn't work. Okay, forget it. The second one from the right is me. That's what I look like. The one to the left of me is Monty Videnius. That's the guy who wrote MySQL. He wasn't involved in PHP, but because of the synergy that PHP always had with MySQL since the get-go, we actually invited him to join our first and last face-to-face meeting where we planned world domination. The guy to his left is really not related. He was the boss of one of the other people, but he did try to run for governor of Nebraska and did not succeed. And those of you, if I'm jumping three people to the left, that's Rasmus working, standing there with a white-sleeved coat. And Andy Gutmans is the guy who's kneeling down next to his wife. And back then, we planned the PHP 4 release. It was, again, the first and last time it was practical to put all the people in the same place. We had some very good positive discussion that eventually led to the release of PHP 4 about half a year later. Last story, before I get down to a bit more technology. So there are all sorts of indicators regarding PHP's popularity. For instance, here having 500 people come to a conference about PHP frameworks, that in itself is a great indicator. And there are a lot of other indicators like the number of books, the estimated number of developers, the number of websites, and so on. But perhaps the best indicator for me was almost 9 years ago, when my wife and I went on a honeymoon to Argentina. And after a very long flight, cab drive and whatever, after probably 20 or plus hours on the road, we get to the hotel. It's a small hotel, like a 2-star hotel, nothing fancy. And we check in, and I fill out the form where you put your name and address and all that, and I hand it in to the clerk. And then this clerk types it into the computer. And as he types it in, after like a few seconds, he asks me, Zeev Suraski? My name is Zev, but most people know me as Zeev because of how I spell it. And I say yes. And then he says, the PHP guy? It's like, wow. So I'm on the other side of the planet, and the hotel clerk in this 2-star hotel knows about PHP and knows and has heard my name. That must mean something. That means that it's really popular. So that was more, that was a much stronger indicator for me than all of the books and conferences and websites, all that. That meant that it's really, really popular. Okay, so getting down to a bit of technology, I'm going to run through the evolution of the major versions. So PHP 3 was released more than 20 years ago, back in June of '98. It's the first time that it was based on the implementation that Andy and I created and aided by several other developers. And it was a full-fledged language. It has the, I'm sure that Marco there will disagree, but it was the full, it was the first time it was a real language with all of the basic tenets of what we know in PHP today, like expressions, even basic objects were implemented back then. Perhaps the biggest advantage of PHP 3, the biggest news, was that it was easily extensible. PHP FI2, if you wanted to add support for a new database, you actually had to change the parser and the scanner and to do some heavy lifting. So you could be a fairly good C programmer and still have a hard time adding functionality to PHP. PHP 3 introduced the notion of extensions that we have all the way till today, and made the extensibility of PHP a lot simpler, and really the number of extensions and consequently the number of different technologies that PHP supported boomed in the year or two after PHP 3 was released. PHP 3, before I go to PHP 4, PHP 3, one thing I can say, remember I told you that we took a compilation techniques course and we felt that we were experts. We were really dumb, actually, because we implemented PHP 3 in a arguably much better way than PHP FI2, but it was really also catastrophically architected, and I'm being kind. It was really slow. It was faster than PHP FI2, but it was really, really slow. It probably had a much more impressive technology than even PHP 7, again, in the sense that it was a kind of a miracle that it worked, but of course, it was really not written in the way that languages are supposed to be written. And we realized that very quickly, pretty much as soon as we released PHP 3, after a very long beta, we already knew that PHP 3 was not the way you properly write a language, and we've begun working on a new implementation pretty much immediately, which became the Zen engine in PHP 4. So it was released about 2 years after PHP 3. The Zen engine was the biggest feature. This time, I can say it was kind of okay. It was written with a compiler and an executor, and it was pluggable. You could add plugin modules like debuggers and profilers and things like that that made things like Xdebug and the op cache possible. Other than the Zen engine, it also introduced sessions, which I'm sure many of you are using, and you can probably find it hard to imagine PHP without. It was the first version of PHP ever to be mostly downwards compatible, because so many people started using PHP 3 that breaking compatibility all across the board, like we did between 2 and 3, was not really an option. And language plugins already mentioned. PHP 5, by the way, noticed that the resolution of logos also improved between the versions. So you can see this is kind of low resolution, this is better, and this is really good. Computers improved, what can I say? So 5 was released in 2004, about 4 years after PHP 4. It changed the object model, which existed since even the PHP 3 days, to something which is more Java-like. In PHP 4 and PHP 3, objects were like arrays, like scalars. Whenever you send them as arguments to functions, or whenever you copy them around or return them from a function, it would actually send a copy of the object, not the object itself. And even though you could work around it by using ampersand quite a bit, sending things by reference, returning things by reference, it made the creation of object-oriented code in PHP and patterns, using patterns, it made it very, very, very difficult and painful. And we decided to actually break compatibility quite substantially in PHP between 4 and 5 and move to a handle-based implementation where objects, when you move them around, unless you explicitly ask to clone them, you actually pass the object itself. And that immediately made PHP a lot more appealing to people who wanted to use it in object-oriented, for object-oriented development. In terms of performance, I didn't mention it before, PHP 4, when we implemented it properly with the Zend engine, had a huge performance boost on top of PHP 3. We're going to see a bit of that in a second. PHP 5 wasn't really faster than 4. The main thing is that we kind of managed to keep it at the same speed, which is why I'm mentioning here that it's not slower. Some people disagree with me and actually say that it was slower, but it was definitely not faster. So here are some numbers on the evolution of performance evolution of PHP. You can see here the last 4.4 version and 5.0 are roughly the same speed. I should note that this is a synthetic benchmark, so something like WordPress or your favorite app was probably had slightly different performance characteristics, but that's pretty much the only piece of code that I have that I can run consistently all the way to PHP 4 and even 3. You can also see that since PHP 5, we gradually improved performance all the time. We invested heavily in performance improvements. So some of the seeds that we've sown in PHP 5.0, we managed to reap in PHP 5.1 and improved performance by like 2.5 times. 2.5 times here is probably 30 to 50% gain in a real-world application, which is pretty good. And then we continued. You can see that from 5.1 to 5.3, there's another substantial, probably 30–40% gain. But then you can see that from 5.4 onwards, the performance gains pretty much plateaued. We didn't manage to squeeze anything substantial. There's probably 5% between 5.4 and 5.5, and then again another maybe 5% between 5.5 and 5.6. But 5% on a benchmark means that you probably can't really measure any difference, any performance gain in a real-world application. So we decided to try and go back to the drawing board. Oh, before we did, let's just put things in perspective and show you how badly PHP 3 sucked. So that's the same benchmark if you put PHP 3 next to it. So it was like, I don't know, 6–7 times slower than PHP 4. And before, yeah, I'm forgetful. Before we get to 7, essentially, let's talk about 6. So how many of you here use PHP 6? Everyone's, yeah, there's a couple. It did exist, which is why the current version is called 7 and not 6, because it did exist. It was actually a project that a lot of efforts went into. As you know, even though a lot of efforts went into it, it never primed, it never was released. It was supposed to be essentially PHP 5 plus Unicode. I've actually plagiarized a couple of slides from a deck by Andrzej Zmiewski, who was the lead for PHP 6. So PHP 6 was really supposed to be PHP 5 with Unicode support baked into the basic tenets of the language, to the basic engine, and things like, again, I can't really point, so you can see there's a bit of German there, so the third letter there is a German lowercase s. So if you use str2 upper on it, the same standard PHP function, the result would be fuss ball. So it would know how to take the lowercase s, which is unique to German, and turn it into an uppercase s. In the same way, there's geek over there, and you use str2 lower on it without having to use any special functions or anything, and it would know how to treat it and make it a lowercase geek. So it was a great premise, but what actually ended up happening is that the project got stuck. Andrei led it, and I think he did some marvelous job leading it, but at some point there was it lost momentum. And what really killed it was when at some point we decided to check, okay, how fast is it? And the answer was not very fast. It was about 30 to 50% slower than PHP 5. And by the way, we were talking about PHP 5.3. If you remember, we've made a lot of improvements since then. So, it was probably even a lot slower. And the bonus was that it also made PHP consume almost twice as much memory because it used UTF-16, which uses 2 bytes for every character, and PHP uses things a lot, not just for values, but also for symbol names and so on. So we decided to kill the project, and I'm not sure, I should really check what this exact second is, but my guess is that that's when Andrei sent the email that he's officially abandoning the PHP 6 project. If you want to see the full deck, you can go to bit.ly/php6 what happened. It's actually an interesting deck. It's written by the guy who led it, so it's subjective, but to the benefit of PHP 6. So PHP 7. So remember the graph, the performance gains plateaued, and we couldn't really squeeze any substantial performance gains anymore from the existing infrastructure, from the existing architecture of PHP 5. So we decided to explore a new direction. That new direction was JIT. How many people here are familiar with what JIT is? Not Git, but JIT. Okay. So for the benefit of those who don't know, JIT is actually a technology that all of you use every day. It's called just-in-time compilation, and it turns a dynamic language into machine code in runtime, and you use it, even if you don't know, in your browsers. In the desktop browsers for sure, but also today I think that virtually all of the mobile devices, the browsers on mobile devices also use JIT. And JIT is, to a large degree, what made some of the really advanced JavaScript-based applications possible. It makes JavaScript great again? I don't know. It makes JavaScript bearable in terms of performance, and actually quite fast in terms of performance. And we said that it made sense to try and use the same technology for PHP. And we started implementing it, and you probably can't see, so I'll tell you, on the right-hand side, you have, the standard benchmarking suite of PHP, and all sorts of synthetic benchmarks. The bottom line is that in our experimental JIT implementation, with JIT off, the test took about 1.15 seconds to run, and with JIT on, it took 0.2 seconds to run. So almost 6 times faster. That's amazing. The same code, unmodified, and it runs 6 times faster. That's kind of almost like the difference between what we had in PHP 3 and PHP 4. So we were quite excited. Just as we were excited when we saw this, we were very disappointed to learn that when we took this implementation and extended it a bit and made it possible to run WordPress with it, and WordPress is a simple enough application that it's usually the first thing that we try with performance benchmarks. We were very disappointed to see that it was not showing us any performance gains. Actually, it was slightly slower with JIT. So we tried to understand why that was. So we worked with people from Intel, from the compilers group, people who really know their stuff, and we tried to understand why it is that we're seeing such great gains with synthetic benchmarks, but in real-world applications, we're seeing really nothing, and even sometimes it's slower. And after we involved the top experts from Intel in doing it, they couldn't tell either. So that was even more disappointing. We did have a theory. The theory that they had, both Dmitry Stogov, which is the guy that you see here, who's the lead performance, the lead person that's working on performance improvement in PHP, and guys from Intel, the theory was that there's a bottleneck elsewhere that is preventing PHP from actually taking advantage of the gains in JIT. It was a combination of, the root cause in this theory was that PHP was consuming too much memory and moving too much memory around. And that also resulted in something called branch mispredictions. It's a performance issue with CPUs. CPUs try to guess all the time what's going to happen. And if they're right, they're a lot faster than if they're wrong. And we're not going to get too much into it. It's complicated stuff. But we had a theory. And this theory, we decided to, after we really came to the conclusion that we are not going to get anywhere with this JIT implementation, we decided to try and explore this theory. The problem with this theory was that we had to essentially scrap all of the work with JIT that we did and put it aside and take PHP 5 again, start from scratch, and essentially try to make the memory structures of PHP 5 a lot more compact. Essentially make them consume much less memory. And that was a very hard project because there isn't really, even with all of the much stronger structuring that exists in PHP today, I don't think there's really a parallel in PHP to something like when you take the very basic data structure in PHP, Z value, and completely change it. You change one file, and then you probably have to edit, I don't know, tens of thousands of lines in order to make it just compile again. And we did it, and we invested several months in doing it. And within about 3 months, we had a version of PHP that compiled, which is a good start. It actually was good enough to run the synthetic benchmark, the same synthetic benchmark that I've shown you earlier. And it was actually good enough to run WordPress. WordPress is not very demanding in its basic version, basic configuration. And then, even though Dmitry I'm not sitting with him, he's based in St. Petersburg, and I didn't see him, but I can imagine that when he ran the benchmark for WordPress, his face must have been something like this. And you can see, these are my Photoshop skills, not very good. WordPress was showing us something like 30% better performance. And that's a real-world application. That's not a synthetic benchmark. Synthetic benchmarks are actually significantly faster. But a real-world app, 30% gains, this is not something that we've seen since maybe the switch from, I think, 5.2 to 5.3. So, and that was just the beginning. Since then, we managed to improve it quite a bit. We moved from a POC to a public repository. We went through a vote, and it became officially the basis for the next version of PHP. Then we had another vote whether to call it PHP 6 or PHP 7. You know the answer, you know the decision. Since the 30% gains that we've seen, we've actually managed to improve it quite a bit. Those are the key changes. It's kind of technical. It makes a lot more sense to you if you're a C developer than if you're a higher language developer. But the biggest change is actually the one that looks the least significant, the 24 to 16, the size of the Z value. That's the basic container for any value in PHP. This is huge. It's just 8 bytes, but it's 8 bytes in something that you use quite a bit all over the place. And the other structures, the second one is also very substantial. And we also managed to improve the performance of the memory manager and reduced it from 20% in WordPress, 20% of the overall execution time to about 5%. So that in itself is quite substantial. So first and foremost, what's in it for you from moving to PHP 7? And let me pause here and ask you, how many of you are still on PHP 5? Really? Okay, you're amazing. Glad. So you don't need this presentation, you're already convinced, but it's really fast. So to put things in perspective, this is, I didn't keep the PHP 3 one here because it would completely make it impossible to read. The synthetic benchmark is almost 3 times faster, more than 2.5 times faster in PHP 7 than 5.6. And the big news is that it didn't stop just in synthetic benchmark. So this here is a case study published by a company named Badu, and they were probably one of the first large websites that moved to PHP 7, and they documented all the same things that they did, and you can actually Google for it and find the detailed case study and read about it, also about some of the issues that they had, because they were really one of the early adopters. And the 2 graphs here, the one on the left is the memory consumption. So it's quite amazing. You probably can't see the numbers, so let me tell you that the memory consumption, the average memory consumption of requests, of PHP requests, went down from 37-ish, about 5. So it's not quite to 0, it starts at 5, but it went down from 37 to 5, and it's pretty remarkable. And those of you who have any experience with performance, specifically in C applications, know that if you manage to reduce the memory consumption so substantially, you're going to see some speed gains as well. And you can see the speed gains in the right-hand graph. The CPU load went down by about 50%, and they actually managed to shut down half of the servers and keep having the same people, and even with some growth. So they estimated the, hello? Yeah? Can you hear me still? Not really. It has a life of its own, this thing. Can you hear me at the back when I'm like speaking up? Yeah? Okay, so let's do that for now. So they estimated substantial financial savings, not just performance gains. And this is something that is really in the PHP's history. You really just upgrade very little changes that need to happen. The main thing about PHP 5 to 7 migration is making sure that you're not using any deprecated features, not much beyond that. You just upgrade to the latest version and you get a huge performance gain. Tumblr case study, same idea. The memory consumption went down substantially, CPU utilization went down substantially. You can probably tell exactly when they moved to 7, right? It's not very difficult. Yeah, you should do it. Here are some semi-synthetic benchmarks. They're not really synthetic, but they're kind of not from live websites, but rather benchmarks that we ran on all sorts of applications. So Zen framework, more than twice as fast. Laravel, also more than twice as fast. WordPress, Drupal, WordPress quite a bit faster than twice, 7 to 5. Any HHVM users here? You're doing this just to spite me, right? So this is not all that interesting, but for people who are not using HHVM, but in PHP 7, in many cases, in most cases that we've tested, really except for MediaWiki, it was actually faster. It's not really all that interesting whether it's exactly as fast, slightly faster, or slightly slower. The big news for HHVM users was that they no longer had to use HHVM in order to stay in the ballpark of PHP. And in many cases, especially in framework cases, which I guess you guys are interested in, it is framework days after all. So heavily object-oriented code is actually faster in most cases in PHP 7 or 7x compared to HHVM. If you want to read a bit more about the performance of PHP 7, there's a couple of other bit.ly links that can be interesting. The second one is a Mandelbrot comparison of all sorts of different languages, including PHP 7, including the JIT implementation. and including even C, which the JIT implementation that we had, interestingly enough, was faster than C in some very specific situations, so don't jump, it can't really be faster than C, but in kind of an average scenario, it could be. I think we're pretty much out of time, so since you already use PHP 7, I'm not going to dive into the different features, but performance was just one of the main tenets, the main features of PHP 7. Maybe just is not the right word because it's probably the most interesting capability. It's, from my experience, that's the main motivator for people to upgrade. And the migration to PHP 7 is happening in a much faster pace than the migration in the past, for instance, from PHP 4 to 5. There's no chance that I would go to a conference hall back in 2006 and ask the audience how many of you are already on PHP 5. But other than the performance, there are also a lot of other capabilities. The ability to recover from errors, all sorts of errors, using time catch. This is huge. And many others. Again, here too, if you need the full list, you probably don't need me, but bit.ly/php7 news would get you to the right place. PHP 7.1, it's not really all that new anymore. It's 8 months old. There are some additional performance gains, nothing nearly as substantial as the jump from 5.6 to 7. But still, we haven't stopped working on performance. There's multi-catch in there are void return types. Maybe I should say that the way we introduce language features into PHP is very dynamic, and it's very difficult to predict what's going to be added in PHP 7.3. We have a pretty good understanding of what's coming in 7.2, because it's already decided, but any one of you can come and submit a proposal on php.net for a new feature, for a new capability, for a new syntax, and it's a big if it's interesting enough, and if you manage to survive the onslaught of internals and kind of explain why it is a good idea, and you can get people to vote for it, it can make it into PHP 7.3. So there isn't kind of a planning for 5 years or 10 years into the future. It's really a very evolutionary project with a lot of community involvement. So a bit about PHP 7.2. I'm not going to talk about the features, but on the performance side of things, we did manage to do a very elegant change that and again it's a fairly big if you have workloads that are CPU intensive, that are not using a lot of database code, and they just crunch numbers, then you can see something like as much as 50% gain compared to PHP 7. That's substantial. What you see here is just how many lines were changed in order to do it. Essentially, 300 lines were added, 124 removed, and most of them were kind of very minor. It's a very kind of like brain surgery, really. Something very delicate, but if you do it correctly, you manage to make a pretty huge change. So that's what, again, Dimitri managed to do in PHP 7.2. It's going to come as a standard part of PHP 7.2, which is scheduled for November, the end of November, if I'm not mistaken. Of course, it's open source, so it could take more. It's not going to take less. That's pretty clear. PHP 8, it was like PHP 7 and beyond, so I don't know what if, when, why, and any other WH question about PHP 8. I don't have any concrete information about it. What I do know is that after PHP 7 was released, a few months afterwards, we decided to revisit JIT and see whether the changes that we did to the language engine, whether they made it more practical to get performance gains from JIT. The bad news is that they didn't. We actually managed to remember that I told you half an hour ago that we thought that JIT was not giving us performance gains because of memory and bench mispredictions and things like that. So it was a nice theory. We had the best people in the world for compilers that had this theory, but this theory was wrong. It didn't make any difference when we tried JIT again on top of PHP 7. Still, we're seeing great results on synthetic benchmarks, so bench.php. The blue is PHP 7, the amount of time it takes to run. The red is PHP 7.2, so you can see it's pretty nice, almost 50% faster. And the yellow is JITted PHP 7, which may become PHP 8, or may not, we don't really know. And the right-hand side, it's another benchmark. It's Mandelbrot, also CPU-intensive benchmark. And again, you can see that the red is much smaller than the blue, and the yellow is even more impressive. Again, like the same experience we had in 2014, the performance gains in real-world applications in WordPress, they're not there. We're not seeing any substantial gains. We're trying to understand why, but I don't think, at this point, we don't have much hope. What I think we're going to do is, even though we're not seeing performance gains in real-world apps, we probably would want to productize it. It's open source. You can actually check it out. It's not done in secret like the previous JIT version. So at some point, we may decide, OK, this will become the basis for PHP 8. And what will happen then is that for new types of workloads, for CPU-intensive workloads, because PHP will then become probably the fastest dynamic language to develop number crunching with. It's already today by far the fastest language. It's way faster than Python. It's way faster than Ruby. It's way faster than anything which is not JITted. If and when we JIT it, it's going to probably become significantly faster than them as well. And with that, and with a 7-minute overtime, дякую.